Right, good afternoon, class. So today we're looking at the homework firstly. The homework was the investigation, not so. Okay. Just need to speak about something there. I had my textbook here somewhere. Yeah. And that was on page. The investigation was on page 246. Okay. So they ask you to measure these lengths here. They ask you to measure the length of AD, the length of DB, the length of AE, and the length of EC. Not so? Okay. Then I want to know, what can you conclude about DE and BC? What can you conclude about DE and BC? They are parallel lines, not so? So you worked out and there were parallel lines then? Then I asked you to complete AD over BD. What did that give you? What ratio did that give you? BD? 3 over 2. Okay, I'm just going to draw it here quickly. Screenshot. So you can see what we're talking about, okay? Alright, so the first question with regards to yesterday's lesson, when I did a proof on the board, it didn't come on the video, no? So in the comment section, you will see there's a link I've pasted there. It will take you to the proofs video. Okay, all the proofs, geometry proofs is in there, okay? Don't forget you are writing on. You're getting two proof, what's the name, questions in the exam. One being the proof of the Proportionality Theorem, which we did yesterday. It's worth 6 marks. And the proof of the geometric sum of formula. That is also worth 5 marks. So go learn the proofs. It's for the exam on Tuesday. In our WhatsApp group, we have put both the videos are linked in as well. No? If you don't have it, just let me know, I can resend it to you. And I'll first ask you why you're not in the group. But anyway. So at this point we see that these lines are parallel. Then we went and they asked you to complete AD over BD. DB, BD, and AE over EC. So when you measured AD, what did that come to be? Sorry? 3, and this one? 2. AE? 6, and this? 4. So when you got AD, it's going to be 3 over 2, and this is going to be 6 over 4, which is also 3 over 2. Not so? So what can you conclude about these ratios? We're going to have to conclude that AD over DB is equal to AE over EC, which is equal to 3 over 2. So the ratios has to be the same. Then I asked you to complete AB. So you got AB over AD. And then you went on and you worked out AC over AE. So AB is 5 over 3, and then we had 10 over 3, not so 10 over 6, which is 5 over 3. Not so? So we have AB over AD was the same as AC over AE. Okay? And again, what could have been concluded at that point? What conclusion can be made? We can say that AB over AD is equal to AC over AE. And that is exactly the theorem we proven yesterday. Okay, just to refresh your memory, the theorem we proved yesterday was if you got, okay, the body is not aligned, I try to align it, so it needs to be restarted, okay? So it's going to look a bit funny. We already know my handwriting is not the best. So the body is not playing along, okay? So you got here AB, let's call this PQ. So you got triangle ABC. The theorem we proved yesterday was if PQ is parallel to BC. If PQ is parallel to BC, then we proved that AP over PB is equal to AQ over QC. That's the theorem we proved yesterday, not so? So if the line, if you got a triangle and you have a side that is parallel to the third side, or PQ which is parallel to BC, then that line will, it will divide the sides in proportion. Okay? That is where we get the proportionality theorem from, that name. Okay? So, the variations of this is all true. We could have said that AP over PB is equal to QC over AQ. And we can interchange. You remember when we did all that different ratios and it's applied here. Okay? So we take the reciprocal, we just take the reciprocal on the other side as well. From here we also know that AP times QC is equal to AQ times PB. Okay? And many other things we can derive from here. I'm going to do one more. AP is equal to QA times PB over QC. What I did was I took this here up and I cross multiplied. You guys all understand that, no? And another, what else can be derived from here is that was A, B, C, PQ. If those lines are parallel, it's also true that AP over, so it's AP over the whole length of AB is equal to AQ over ACS. Can you see that, people? If we use this rule, this proportionality theorem, we write prop theorem, proportionality theorem, and importantly you must say that PQ is parallel to BC. Very, very important to say. Alright. And all the variations is also true. Which means to say that AB over AP is equal to AC over AQ. And we can interchange this as needed. And we can cross multiply. And all of those things again can be applied. Do you guys understand? I'll do one more. And then we're going to look at an example dealing with this. Okay? Or am I talking too much already? Yes. Okay, this will be the last one. So we got A, B, C, PQ. Okay? If I say BP over AB, then what is that ratio going to be equal to? It will be QC over AC or CA. And what's our reason here? The proportionality theorem with PQ being parallel to PC. People, if you're going to leave that out, you're going to lose the mark. Okay. So that deals with investigation 1 on page 246. We did the theorem, the proof of the theorem. As I said, the theorem is going to be tested. The corollaries is basically the changing and the reciprocals of the ratios and all of that, the interchanging and all that. That is what we did. Is basically what can be derived from the example 1. Don't worry about that. Let's go straight into example 2. Example 1 is dealing with exactly what I explained now with that 3 different triangles, with 2 different triangles, okay? But they just have a third triangle here. Alright. So, example 1 and what I've explained is the same thing, okay? We're going to go straight into example 2, and example 2 is on page 248. Example 2, page 248. Okay. So in this example here, we are told that in triangle ABC. So normally they introduce the big triangle, the big triangle. And then we are told that BE is parallel to BC. Sorry, DE is parallel to BC. Okay? So if they tell us this is parallel, what comes to mind immediately? The proportionality theorem must come to mind immediately. So if that is the case, what do we know? We know that AD over BD equals AE over EC. We also know that AD over AB is equal to AE over AC. We also know that BD over AD is equal to EC over AC. Do you guys understand that? So that's the relationship that exists when those lines are parallel. That must spring to mind immediately. And in future, when you see a triangle and you have a side that is parallel to one of the sides, think of that in that term, in that line. Even when it comes to analytical geometry, same story. You see a triangle with a side parallel to that, we can apply proportionality theorem. Okay? Then we are told that AB is 28. So we go here, AB, and you do the same in your diagram. Okay? You put the, not in the textbook, you must supposed to be drawing it now. No? AB is 28 millimeters. Then they tell us that AE is to EC as 4:3. Now that is a ratio to us, not so. Now you get many people that likes working with ratios. I don't like working with ratios. I like working with fractions. But if you feel that you want to work with ratios, no problem. I can mark it for you. I know how to mark it. But what I do is I always change it to a fraction for some reason. So I know that AE over EC. What do you think that is going to be equal to? 4 over? Not so. Now does that mean to say that AE is 4 centimeters and EC is 3 centimeters? It could be, but it's not necessarily the case. This could have been 400 over 300, not so? It could have been 12 over 9. It could have been 4 million over 3 million. It could have been 16 over 12. Do I have that? No. You understand? So that ratio of 4 over 3, which is AE over EC, that could represent any of those. It could have represented an infinite amount of ratios or fractions in this case. Not so. So instead of guessing and saying it's 4 and 3, what I do is I introduce a k here. Okay? So I put here a k and there a k. Just a reminder again, why am I putting a k there? Because it could be anything. However, if I simplify 4k over 3k, what would I get? 4 over 3. The k is almost cancelled. Not so? Okay. So what I do is I introduce a variable. So you see you got AE is 4k. So AE is 4k. And EC is going to be 3k. What would AC be? What would AC be? 7k. Can you see that, people? I'm moving too slow now. Yes, okay. So that if needed, the Zhou length is going to be 7k. The question says determine the length of BD. So they want us to work out the length of BD. Okay. Just leave it so. They want us to work out the length of DB. So what ratio do you think we're going to set up? It's going to be dBs over. Do you think we're going to go with AD? No, why? There's nothing there. I'm going to go with AB. Yes, why AB? Because we know that is 28. Not so. And this is equal to what? So BD over AB is equal to EC over the Zhou length, which is AC. You guys understand? And what's the reason here? The proportionality theorem with DE being parallel to BC. Okay. So DB is what? What's the length of DB? We don't know. It's what we're going to calculate over AB. 28 is equal to EC 3k over 7k. Okay. Now what? Now what do we do? Sorry about this one. This board is jumping all over the place. Okay, now what do we do? Cross multiply. Firstly, that case will cancel, definitely. Not so. Will the case not cancel? Okay. So if we cross multiply, it will be 7 BD is equal to 3 times 28. How do we get BD on its own? Divide by 7 both sides. 28 divided by 7 is 4. 4 times 3 is 12. That will be 12 centimeters. If it's millimeters, it will be 12 millimeters. Okay? I think it's millimeters. Yeah. You guys understand? Right, let's gonna do it again quickly. Is it okay if I do it again or can I move on? Huh? One more time, okay? I'm gonna do it a bit faster now, no? Okay, so again, we are told that in the diagram, in triangle ABC, BD is parallel to DC. So these lines are parallel. If the lines are parallel, we know it's going to divide the sides in proportion. So AB is 28, so there goes 28 there. 28 millimeters. Then AE over EC is equal to 4 over 3. And here I introduce my K. Okay? So there's 4K, 3K. So if you got AE is 4K and EC is 3K. And we say the length of AC is going to be? The length of AC is 7K. Okay. Then the question says determine the length of BD. So what do I do is I say, okay, there's BD. What do I have? I have AB. So I say BD over AB is equal to EC over AC. And the reason there we said is the proportionality theorem. We name the parallel lines. The DE is parallel to BC. So what is BD? It's going to remain BD over AB, which is 28, equals EC, which is 3K, over AC, which is the whole length, is going to be 7K. So from here it's just a matter of simplifying. Okay? So that would simply be, the K's cancel, cross multiply, so it's going to be 7BD equals 3 times 28, divided by 7 both sides, so BD works out to be 12 millimeters. Okay, a sum like this is worth 1, 2, 3, say 3 or 4 marks. Okay, geometry is it's marks that we never normally get. Not so. Not say yes, man. You say no. So we know our geometry. Okay. Let's look at example 3. And spice up your life quickly. Example 3 is on page
249.
Okay, draw the diagram quickly. We're going to do this one together. Alright, example 3 on page 249. We are told that D and E, so we say D and E are points on sides AB and BC, respectively. What does respectively mean? In that order. In other words, D is associated with AB and E is associated with BC. That's what basically respectively means. Okay? Of triangle ABC, which is a big triangle, such that AD is to BD as 2 is to 3. So I said I work with fractions. So AD over DB is equal to 2 over 3. And what do I introduce here? Okay. Why? Because that 2 over 3 is a ratio in its simplest form. Okay? So you got AD, and I fill it in here. It's going to be 2K, and BD is 3K. So what is the length of AD? Sorry, AB? 5K. If needed, it is 5K. You all okay with that? Right. Then we are told, and this is how you tackle the geometry. You'll see also when I did the circle geometry as well. As I'm reading, I extract that information and fill it in on the diagram. It makes life so much easier. Okay? I know some of you are far past that and you can just fill it in afterwards. But our majority of us, we need to write it down first. Okay? So BE is equal to 4 over 3 of EC. Hang on, this is a bit different to what we have here. But we have what we are normally dealing with. Not so. So we rather get it in the form that we are familiar with. So it's going to be BE over EC. Why do I divide by EC both sides? So I can have my ratio on the one side. Does it make sense? So what's going to happen is EC cancels EC. So BE over EC is equal to 4 over 3. Okay. Now what do we notice? Is BE and EC. So what do you think we're going to put here? We're going to put the 4K over 3K here. What do you think? Okay. Why wouldn't we put a K there? We shouldn't put a K, but why shouldn't we put a K? Because K is already assigned, K is already used. So in future, if you had used K, use a different variable now. Now we start at A. So 4A over 3A. If you need another variable, then we go B, C and so on. But never do we need more than 3. Why? Because a triangle only has 3 sides. You see that, people? So let's fill that in. What would this be? 4A is to 3A. So you got BE over EC is 4A over 3A. So you fill that in. So if we're talking about this length here, BK and KE, or KC, or CB, it's always going to be involved with that A. You see that, people? So this side of the triangle, which is length BC, will always be associated with A. The side AB will always be associated with a K at this point. You guys understand? But if you had named this initially A and that B and so on, it will give you the same answer. Okay? You don't have to start off with a K. Some do it without the variables as well. Okay? It's just a very complex thinking if you do it without the video. You all okay with that? Right, so let's carry on reading. Then we are told dk is parallel to AE. So if dk is parallel to AE, what do we know from here? We know that BD over AD is equal to BK over KE. Can you see the triangle line like this? With these lines being parallel. So is that over that equals that over that? Oh, sorry. That over that would be equal to this over that. Not so? Also, that over the whole length is going to be that over the whole length. Or that over this would be that over that. You all agree with that? So whenever you see these two parallel lines in the triangle, you see things like you look out for the sides to be in proportion. Okay. Let's take this one back again. So we said that these lines are parallel. Okay. And AE and CD intersect at P. So this is, yeah. So it intersects at P. Also, I try not to overpopulate the diagram, okay? So they intersect at P. Find the ratio of CP is to PD. So they want you to find the ratio of CP, which is this length here, is to PD. So this alright. But looking at this, CP, as this is CP over PD, you all agree that CP over PD is the same as CP is to PD. Right. So CP over PD, I marked it wrong. CP over PD. As it. So what is CP over PD also equal to? Remember, here's the parallel lines, no? Here's your triangle, and that line is parallel. So CP over PD is equal to what? Sorry? CP over PD is equal to CE over EK. Do I have the length of EK? No, so that is what I need. I need to find EK first. Not so? How can we find EK? Now we look at this side of the triangle. EK, what do we have? EB. Can you see that? So EK over EB is equal to? Equal to what? Here's your triangle line. Sorry about this, man. The board is jumping around. EK and EB, there's your triangle, no? So EK over EB is equal to AD over AB. Does it make sense? Right. Let's take this off here. Let's see it again. So it's going to be, I'm going to name the triangle, okay? So later on when you're going home and you're going to do it again, you can see which triangle you're working with. In triangle ABE. So it's a good habit also of writing this down like this, okay? So there's many triangles you're working with here. Okay, so in triangle ABE, we can say that KE, since I want to work out KE over BE is equal to dA over AB. What's your reason here? The proportionality theorem with AE being parallel to DK. KE is what I want to work out, so and KE over BE, which is 4A, is equal to dA. What is dA? 2K over 5K. Why didn't I say KE over KB? Who can tell me why didn't I say KE over KB and I said EK over EB? Why did I say KE over EB instead of saying EK over KB? We don't have the length of BK. We have, however, the length of EB. That is why I went with EB. Why EK? Because I want to solve, I want to calculate EK. Does it make sense? Okay. So now it's just a matter of simplifying. So that cancels that. So I'm just going to take that up. We're going to cross multiply. It's going to be 5KE is equal to 8A. 4A times 2 is going to be 8A. So KE is going to be 8 over 5, 8. So this here, KE is 8 over 5, 8. Okay. Now let's look at the other side. I need to take this off. I want to keep the diagram in focus. Can I take it off? Who's still writing? No? Right. Now coming to what they want. They want CP over. So we know that CP over PD is equal to. So CP over PD is equal to what? CP over PD is equal to CE over EK or KE. What's your reason there? The proportionality theorem with PE being parallel to DK. You see, DK is parallel to PE or EA, doesn't matter. Now CP and PD have no length on that, so that remains CP over PD. But EK is what? 8 over 5. What is KE or CE? 3A. So it's going to be 3A divided by 8 over 5A. So CP over PD is equal to, should be 15 over 8. Okay, just put in the calculators there. It's going to be 3 divided by 8 over 5. Because you're 15 over 8. Okay. Something like this, 8 marks. 7 or 8 marks. One, 2, 3 on this one and 4 on the previous one. So let's say 6 marks. 7 is generous. Okay. Will you guys understand? Right, let's see what example 4 holds for us. Example 4, I'm going to go a bit quicker through it as we know we've got 5 minutes left. And example 4 is on the next page. Example 4 is on page 250. In example 4 we are told that in triangle ABC, again that's the big triangle, AB is parallel to FD. So AB is parallel to FD. If that is the case, what do we know? That AD over DC is equal to BF over FC. Not so, for those lines being parallel. So that comes to mind, okay? Just keep that in red there. Then we are told that, all the best, no? Then we are told that AF is parallel to FD. Okay, the video will be online later. You can just...
Okay.
You guys can read now. Those of you playing away. AF is parallel to DE. So if AF is parallel to DE, then what do we know then? Then we know, let's put this in the right place. AF is parallel to DE, then we know that DC over DA is equal to CE over by EF. That's all, people. These are your parallel lines now. And all the other variations is also true at this point. But what I do is when I do something like this, I draw those arcs in. These arcs, I draw it in. Lightly with a pencil. And then I know, when I look at the diagram, where the parallel lines are and what is the relationship between the sides as well. Then we are told that if E over EC is equal to 3 over 4. So what do? I introduce a K. So there goes K and a K. So if E is this little one here, is 3K and EC is 4K. So what is FC? What's FC?